Afternoon, everybody. I hope you've all recovered from lunch. Welcome. This is the Designing the Grid of the Future Using Storage to Improve Every Aspect of the Utility System. I'm going to be your moderator today. I'm Mike Gergen. I'm a partner at Latham and Watkins, which is a large law firm, help run the energy practice there. I also have the privilege of teaching energy law at a law school in New York, and energy storage is really unique. It's actually one of the last parts of the course I teach because you have to understand all the things that go into sort of what the electric systems, what the grids are, how they work, before you can even begin to think about batteries. But batteries are, we all live with them. Everybody in here has at least one. Some of you probably have two. Some of you even have three. Batteries in our lives are ubiquitous, right? They're not when we talk about the grid. But perhaps they will be, and that's what we're going to talk about today. I mean, we're in a world of not a lot of grid-level storage, particularly with batteries. Maybe we'll be to a megawatt by sometime next year, but there's certainly some folks and some people even on this panel who have companies that have big plans in this area. So this could be something where, just like in less than a 15-year period, we went from not having these to where we all have one and maybe two batteries on us at all times, where batteries will be ubiquitous on the grid as well. And with that, I would just want to briefly introduce our panelists today, going from my left to my right, starting Dr. Peter Muhoro, who's the Chief Strategy Officer at Pedernales Electric Cooperative. To his right is Jeff Gates, who's the Vice President of Sales at Olivo. To his right is Eric Schrock, the President and CEO of Indie Energy. And to my immediate left is Cliff Braddock, who's the Manager of Distributed Energy of Constellation Energy. And we're just going to jump right into questions, and we're going to try to make sure we have some time at the end for questions from you, and hopefully you'll be an engaged audience. I know you just ate lunch. It could be difficult, but let's all try. Because honestly, when it comes to energy storage, we're just starting to figure this stuff out. None of us really know a lot. We're all learning as we go. These guys probably know more than most of us, so hopefully we can learn something, but you may have some things to add as well. As you probably heard over the last couple of days, and I know I sat in one of the panel discussions this morning, we all know that the grid, as we know it today, is undergoing a major and perhaps rapid transformation, especially with the increasing deployment of intermittent renewable energy and distributed energy resources. And my first question is for Jeff. What role can or will energy storage play in this transformation of generation and transmission and distribution systems?
Thanks, Mike. And just as a way of background so that you can know who you're talking to, Alevo is an energy storage provider. In my prior life, I worked for Duke Energy, which is one of the larger utilities, and also was responsible for development for the largest energy storage project in the great state of Texas, out in No Trees, 36 megawatts. And so I've been basically focusing full-time on energy storage for 7 years now. And from when I first started and people said, what do you do? And I said, I work for developing energy storage projects. People had no idea what I was even talking about. Now there's a media article every day about somebody doing something with energy storage. And so when I said what I do, people are like, oh, okay, I get it. So I'm going to steal a quote from Catherine Hamilton that she has used, and I don't know that she invented it either, but it's storage is it's like bacon; it makes everything better. And I think that's really what I see as we move forward, as we deploy more storage, and how it's going to help. It makes all of those things that you mentioned better. It makes generation more efficient. It makes the better use of the distribution and transmission system. Battery storage in particular, and there's many kinds of storage. There's pump storage, thermal storage. There's all kinds of things. I think batteries probably get the most attention right now, but there's huge locational benefits that you can provide. As we move away from this, central station model, and this has been on in half the panels over the past couple of days. Is the grid was designed with a big central generating plant, wires, end-use customer. Everything goes down a one-way street, and that's it. We're moving away from that world. We're moving towards generation that's out on the distribution grid. We're looking at two-way power flows. We're looking at more empowered customers. And storage is going to be key in enabling all of those different technologies because it provides so many different values across the grid. And I think one of the the visions that people have is that, right now it's somewhat of this exotic thing. People, what is energy storage? 5 years from now, it'll be as common for utilities to be thinking about buying a transformer or a wire or a piece of generating equipment as it is storage. It's going to be no different than the rest of the things that they have on their menu. Okay, it's, we're 5 years from that, but that's my goal. In 5 years, it's no different than anything else.
Great, thank you. Cliff, I wanted to ask you, because it's, Jeff talked about this in sort of a general sense. If you could kind of give us a real world example, and we're sitting here today in Austin, Texas, a Texas-based example of sort of energy storage, and how is it, a particular application of this could make the grid more efficient and reliable?
Okay, very good question. So it's okay just to ask a few questions of our esteemed
Absolutely.
audience, because
Sure.
after all, most of the knowledge is probably sitting right there in front of us. So we just prompt some of those questions. So I'm just, if I may, try to have a little fun here. What would you guys say are the buzzwords of our energy industry right now? What are we trying to attain? And you've had the answers thrown at you through all these other sessions. And if you don't start coming up real quick, I'm going to give you answers. But some of them start with R, resiliency, reliability, and how about sustainability? I'm not hearing a whole lot of that. And then cost is always there. Can our heads go up and down and not left and right?
Did we miss any buzzwords there?
So what else adds on to that? Anything? Customer-centric? Yeah, that's big time. So customer-centric would be because the customers want all four of those things. So you got to comply to get all four of them. So my point is, I believe that if we want to deliver on all 4, 5 with the customer involved, that it sounds kind of strange to say this. It's not about how the technology of generation. It's not the technology of energy efficiency. It's not even the technology of distribution. It's the technology of storage. I mean, you got to think about that for a little bit. Why is storage so important? And I believe that you can't get the most, how do you get more sustainable? Well, that is a function of, the source of the generation and how you're going to use it. And you can't maximize that benefit without storage. And you start thinking about resiliency, a storm comes through, how are you going to recover? Well, that part of the answer should be. And then what about the reliability, the N+1? I know I've seen some of you guys coming in here, and I know there are people in here much smarter than me, particularly from one of my former employers, Mr. Carl and others from Austin Energy. So anyway, you're not allowed to answer these questions. So anyway, I believe that if you want to deliver an energy system of the future, like microgrids, which I'm working on now, the storage is, you can't have a successful microgrid without storage involved in it. So we're seeing storage take off. I bought a PV system just recently from, where are you, right there. And I was just telling him that I am very pleased with my PV. It gives me something to do every 5 minutes of the day to see if the sun's shining at my house or not. And so it's really drove my productivity way down since, but financially we're going to be ahead. So anyway, if the lights go out, from the grid, do they continue on with my PV? No, because he needs to talk to Debbie over here, and you guys need to come together to work on protocols that allow, small scale storage to, to give us the benefit even during a grid outage. So I'm not directly answering your question, but I'm getting all of my concerns out on the table here. I'm
checking them off.
I guess it's like, you give a mic to Donald Trump and he doesn't stop either. So
He's making the grid great again. Okay.
That's right. But anyway, and who all went on the tour on Monday out at the Pike Powers? A couple of us did. And so, are you an engineer? Okay. Did you catch everything that he was saying? So I'll tell y'all one time, and you can pick this up or not, and the people from Austin Energy have got to plug their ears on this one. But what I saw was that electronic switching of inverters can create total harmonic distortions that the utility is currently eating up and not really billing us for it, quite frankly, that it's something that's going into the grid. And I'm thinking storage is a solution for that. Localized power factor correction can be done at the consumer level. Even at my house, a little, 10.93 kilowatt system that I have. So my point is, we're at the forefront, I believe, of his industry, where this issue of just having a battery that can defer a demand or store an energy is too simple, because the storage mechanisms can be quite a service. And down at Alamo 1, do y'all know anything about that? At San Antonio, right at a big solar farm, the battery that's down there, a megawatt. And if I understand correctly, that battery is providing ancillary services back into the ERCOT grid. You asked for an example. It's sitting down there. And I believe every day they will tell you that it's making money for them in a variety of measures, not the least of which being just simple storage, but it's providing voltage support, it's providing frequency stabilization. So I'm just saying that example could be located at every one of our houses on a much smaller scale. So my challenge to this industry is figure it out how to offer the list of services that Debbie needs with her utility and the grid operators need. So, and make it friendly for me at the house so I can keep my lights on when the power goes down. And anyway, I'm done with my preaching right now. So, but back to my job though of designing a microgrid, we have to have storage in there to provide those 4 features: the resiliency, reliability, sustainability, and cost effectiveness.
Great.
Sorry about a long answer, but there you go.
Thank you. So, Eric, I wanted, because it's one of the things that people talk a lot about with storage is its ability to time shift between production and use. So it's oftentimes referred to as the holy grail for renewables. And this kind of goes to, I think, a point Cliff just raised. Should we be thinking about storage as more than just this sort of notion of time shifting? Should we be thinking about it as potential for not only shifting production and use in time, but also in space?
Sure. No. Good question. That's where everyone's mind tends to jump when you talk about solar plus storage. Is just kind of this like bulk shifting of energy from one time of the day to another time of the day. So just quick background for you guys. I'm an electrical engineer by background, so I tend to think of the world kind of in a technical way, but I slowly have been bleeding over to more the business and the economic side. So I'll try to mix those two as I answer the question. Disclaimer: I did eat the pork chop for lunch, so I'll try to. Most of it, like I started to finish it, but then I was like, man, I would just be totally incoherent.
Doggy bag down there, okay.
No, it was that pork chop. Gosh, holy cow. So I would think back, to answer this question, like, should we be thinking about this? Is time shifting of energy, like what, storage is all about for solar? And I think back to a few years ago when I first started to kind of bleed over into the economic side. And started crunching the numbers and looking at value streams and like what does this stuff have to cost to make sense? And at the time it was about 20 cents a kilowatt hour to time shift. So this means if you want to have an energy storage system, you want to charge it at one time of the day and you want to discharge it at another time of the day, you needed the difference in either price or value of that energy to be about 20 cents a kilowatt hour to make sense. And so today, it's more like 10 cents. So an interesting point is just how fast this, these sort of costs have been coming down for the technologies. But, even today, if we take this 10 cents a kilowatt hour number, there's pockets and places where it works out, but like on the large scale, it doesn't pencil just doing this. So absolutely, right? Like the things Cliff was talking about, we should totally be thinking about all the different things that a storage system can do other than just the time shifting of energy. Myself and my colleagues, it's one point we're really interested in, and so we participated in a hackathon this weekend. There was NREL put on a hackathon as part of this conference, and it was the first time we'd done anything like this, but really what their point was NREL has all of these data sets and databases which they want to promote and make people aware that they exist. So they want people to make use of this data, but they also wanted people to come in and just kind of address problems in the solar or solar plus storage industry. So what we came in and really did, we wound up winning the hackathon. If y'all weren't at the Monday thing, they announced this at the conference. But what we did was we looked at some of the tools, the analysis tool sets that are out there. And I think there's a lot of value that's missed with storage. Like people kind of evaluate these things on too narrow a view. And so in the hackathon, we built some tools that looked at some of these value streams that often get overlooked, like clipped energy capture. And I'd love to go into some of these. But for the sake of time, I'll just pass through. But if you'd like to chat afterwards, I'd love to chat about this stuff. But a lot of these sort of value streams that aren't well understood are out there, and they're very real. So when you know, even when we were presenting this at the hackathon, like a lot of the judges' eyes were kind of, you know, I could see they were a little surprised at some of these value streams that they didn't really realize or hadn't thought about. So, you know, I hope even, you know, right now it's necessary. If you want to do storage, you have to be thinking about other things, else it really isn't so economical with these single use cases. But, you know, even as the costs keep coming down, and they will, you know, over the next 4 or 5 years, we're going to see a much different price point than even what we see today. You know, I hope we continue to think about this in sort of a bigger way, you know, at all the value you can extract out of these resources. Because even when these sort of single stream, you know, single use cases do make sense economically because the costs have come down enough, you know, I hope we're not leaving all this value and all this capability on the table.
Great, thank you. Peter, you're our one panelist that's, you know, here from a utility, and I would really like to hear.
Well, Jeff is recovering utility.
You know, first question for you is, because it's, in terms of storage, looking at it from a utility perspective, do you see it being deployed at a larger utility scale or at a smaller distributed scale or a little of both? And what are the trade-offs between sort of the, you know, deployment at the utility scale versus the distribution scale?
All right, just, and great question. I think I can cover it in several different areas. Just for background, Pedernales Electric Cooperative, we're a local utility here, distribution electric co-op, largest in the nation, west of here, about 290,000 accounts, and an area of about 8,200 square miles. So very high density and very low density as well. Our western territory is about 1.7 meters per mile, and as we get closer to Austin, we're in the 20-something accounts to a mile. So very interesting dynamics when you think of the question you just asked, because we've got a varied territory, which actually is a very good representation of what the U.S. grid looks like. So when you think of that question, you ask yourself a few things. Why should a utility think of storage, just in general? We're known for reliability, 60 minutes when it comes to SAIDI, so pretty good for just to be out on average an hour out of 87, 60 hours. You know, cost of power here in ERCOT, $24 a megawatt hour average for 2016. It's 2.4 cents kilowatt hour. That's cheap power, right? So you start asking yourself, why? I mean, business is great. You know, why would you bother with something that, when you just think of that right away, it may not make economic sense? But when you really think of it, and I think my fellow panelists here really touched on it, that storage has a lot more than what you can see beyond just those basic dynamics. You know, a lot of it comes down to culture and how you see it. Peter Drucker says it best, you know, culture eats strategy for breakfast. So you could have the greatest idea, but as long as the culture is the same way of thinking, you can't get things moving. So when you look at the utility side of, on the utility scale side of it, and we peak at about 1,500 megawatts, so a little bit bigger than the General Electric Co-op, but still not as big. But when you look at the dynamics of what can storage do to our system, we see it having impact on both sides of it. So I'll start off with, when I think of my rural areas that I've got really long feeders, a lot of it comes down to in cases where, when I look at our line extension policy, for example, we only cover up to about $2,000 of that cost to the consumer. If they're really far out, that cost could be in the thousands that they have to come out of pocket to consider doing this, because it involves us having to upgrade, say, a single phase into a 3-phase and that kind of thing, all for one customer. So now you ask yourself, can a distributed storage system be what provides value at that very end consumer? And so we think that that is a solution, and we could see that in a lot of those rural areas, that becoming more and more things that get deployed, even from the utility standpoint, deploying them, because it can, and maybe even owning it and providing a service to that end consumer. So that's one way to look at it. When we look at the larger scale side of it, we've got a lot of dynamics. We've got very dense territory. We're growing really fast. We added about over 12,000 accounts last year. So, and if you want to put that in the dynamics of a co-op, the average electric co-op, distribution co-op is about 20,000 accounts. So about every 18 months, we're adding, a new electric co-op here in Texas. When they say everything's bigger, it is true. Everyone's moving here. So that being the case, it comes a lot of questions on when you look at your substation and the load that you're currently having to deal with and the time constraints of that load. Do you consider an upgrade to your substation, or do you consider some of these technologies? And so we think, and I think that it's going to go both ways, but as we see more and more development on the battery side, that it becomes more and more economical. I still have to go back to, I've got cheap power, I've got high reliability, so how do I explain to my board that I want to do this thing that costs this much? But when I begin to play these other areas that, and to be able to show how this plays out, I will say, going back to Peter Drucker's comment on culture, the reason why it's a little bit different to do this, if you think of it, for example, today, if I ran the economics of a 2 megawatt, 4 megawatt hour battery, the most lucrative way to run that battery on my system is frequency regulation. We're a distribution utility. Do we really care about frequency regulation? So our employees are not thinking that way, are not thinking that that's a solution, but now, can that battery provide other benefits beyond what actually pays the battery off? And so that's the thinking that needs to happen.
So it's a two-part follow-up question
Sure.
to you, Peter. The first is your co-op from a planning perspective, because I know you do integrated resource planning. Sort of how do you think about storage in the context of planning? And then a broader, more sort of policy question. Imagine you're sort of doing policy for other utilities.
I spent my share of time in DC, so I'm very familiar with that.
How should utilities be thinking about storage from a planning perspective? Again, there's a lot of utilities out there that are engaged in integrated resource planning or some kind of long-term planning. How should they be thinking about storage?
Well, I think, so I'm going to address that question from different angles, and I'll start off with a comment: all politics is local. So it really has to boil down to each utility and how you function. Co-ops a little bit different for the most part of it. 7 board members, 4 votes, I get to do what I want to do, or at least what they voted for me to do. Munis, city council. IAUs, rate case. Things are very different, and some co-ops are PUC mandated, so they have to go through rate cases. We're one of the few distribution co-ops that actually go through an integrated resource plan, and it's an interesting challenge because storage is not the first thing. In fact, even we had to be the ones to push to say, can you include storage in this discussion, even though we knew it's probably like including French in an English document. That's what we knew that it would look like. But the reason why we wanted to do it is, one, to not necessarily to show that there is potential when you play with your sensitivities of where storage can actually have some dynamics. Here in ERCOT, my cost of transmission is determined by the average of 4 15-minute intervals in June, July, August, and September. So that's $80 million or so that we're spending annually on cost of transmission that I have to think, how do I lower that, right? And that is 4 15-minute intervals that determines that. At any given time, and knock on wood, it doesn't happen anytime soon, but cost of power could go to $9,000 a megawatt hour. So as we think of planning, we have to think, what are those scenarios what's the worst case scenario? And this is where we've began to factor in things as storage, both at the utility scale and at the distributed side of it, to say, how does that, and then in fact, if you, including solar with it, does it even provide a bigger benefit? So we've had to change our planning to go to that perspective of saying, what is the worst case scenario, and what are the technologies out there to say, can they, bottom line, help to move the needle? So that way we have an idea of, if this was to happen, this is the reason we need to do this. For overall utilities, I think that I think there's a lot to consider in terms of how policy shapes up in this. I do encourage everyone to get involved, and both Jeff and I sit on the board of the Energy Storage Association, and the annual meeting is coming up in Denver in April. But it's a great place for each utility to sit at the table and talk about how it comes together in terms of policy, because what affects Duke, for example, may not necessarily affect me, but somehow we find a common ground that we can move the market to where it needs to be, because our goal should be to move the market where it makes it affordable for us to implement these things. So that's the way we should think of from a policy standpoint, is how do we get these guys to make those costs come down so that we can actually get engaged in it more.
Okay, and then Jeff, I have a question for you, sort of following, because that's the utility perspective now, kind of from the manufacturer, developer perspective. There's been, and it's been alluded to here, and there's been in some of the other panels today and over the week, this notion of storage as providing stack service. How should storage be compensated for providing stack services? Because some of those services may be things that are market-facing, and other services may be ones that we sort of think is traditionally being cost-based services.
Yeah, and I was going to say, as Peter said, I'm a reforming utility guy, but I'm not fully reformed yet. But I think that's one of the biggest issues that we saw when I was sitting inside the utility is, Duke had done 7 or 8 pilot projects. They knew that the technology worked. But how do we go about deploying it? And this goes into, relates back to the last question about planning. And, the problem ends up being the utilities don't plan the system the way they operate the system, okay? They operate the system looking out at the next 5 minutes, okay? When you do an IRP, you're looking at 2020, what's my peak megawatt need on the system in 2020? And I need to have enough generation to serve that, plus a 10% or 15% reserve margin. But I don't care what hour of the day in 2020 that peak hour hits. I just need to know I need to have enough generation to meet that.
And let's not forget to add on long-range planning for utilities was always in the 15-year, 20-year, 30-year planning. And so very different when you look at some of these technologies.
Yeah. And back to the audience participation section, segment of the afternoon. How many people here think that energy storage is expensive? Raise your hand. Okay? Just about everybody. Okay, so I'll ask another question. Is a car expensive? A car? Yeah. Okay? But people buy them, right? Why? If it's so expensive, why do people buy them?
You have to get a value.
Because they provide, the value that the car provides is greater than the cost, okay? Is a bike expensive? Well, a car is expensive relative to a bike, but it does different things than a bike does, okay? And storage, is it expensive? I think it depends on the perspective. If you look at the values it provides are greater than the cost of what the storage system is today. It doesn't need to be some magical $100 a kilowatt hour price 10 years down the road. Storage today is cost effective if you actually value it. And this goes back to the question that you really asked was, how do you value it? And I think that's where we get into the dichotomy right now. Is that there's been a ton of storage that's been built in PJM, okay? Pushing 400 megawatts over the past 3 years. That's not DOE funded. There's no ITC, there's no PTC, there's no incentives, there's no rebates, there's no anything. Why are people building that storage? Because it makes money. It's a commercial decision. I can make a nice return, and I'm providing regulation in the PJM market, okay? There's a single value stream. Vertically integrated IOUs, they could capture that value, but they just don't have a price on it. So you run into this, in the IOU type markets, there's a price for different things, and I can value what storage is with a price, but I may be precluded from capturing all those values because sometimes I look like a generator, sometimes I look like a wire, and I can't get both of those pieces of the pie to the same party. In a vertically integrated utility, all those pieces of the pie get eaten by the same guy, okay? I can eat all the pie and enjoy all the benefits. I just have no idea how much that my enjoyment is worth, because there isn't a specific price for regulation. There isn't a price. I can sort of value a substation deferral. I can look at a few of the different pieces, but I can't look at all of them. And then the other problem goes back to the bacon question are the stacked services, okay? Some of the stacked services are, I'm making my generation fleet more efficient. It's the Toyota Prius argument for the electric grid, okay? I'm starting and stopping a lot of those coal units. I'm ramping them up and down across the course of the day. I get much better gas mileage, quote unquote, out of my fossil fleet by using storage to do that. Some of the value then accrues because it's a substation deferral. Well, there's a vice president of utility that's in charge of the generation fleet. There's a different guy that's the vice president of distribution. There's a different guy that's the vice president of transmission. Each of those guys may say the storage costs $1 and I get 50 cents worth of value out of it, okay? But I only get 50 cents, so it doesn't make sense. If we each get it, then there's $1.50 of value that's there from the stacked services, but we just can't coordinate within the silos of a utility to get them to make the right decision and think about the problem correctly. So I think that's where, as Eric pointed out, you can't just think about time shifting of energy from, the 2 to 4 p.m. time slot to the 4 to 6 time slot once a day. It's just not going to pencil. You have to get the stacked services. Some days it looks like a peaker, some days it's looking like ancillary services, some days it's spinning reserve. All of those different things are things that storage could provide, and you just have to figure out ways. The compensation model is it's probably going to be rate-based in that there's a few things that will be market services, but a lot of it is you just have to figure out how to get the utility commissions to allow you to capture those benefits.
So the way you're describing this is storage, and some people have thought about it, traditionally as it's neither fish nor fowl. It sounds like it's fish and fowl. And given that it's fish and fowl, and maybe fish is cost-based, fowl is market, and this is a question for either of the two of you, if that's the reality of what storage is and how it's going to have to be paid for, who should own it?
Yeah, good question. I mean, I'll take a stab. I mean, I don't know that there's a single answer. I mean, when sort of a theme in the conference, which I was incredibly interested to come here and listen to, like how are people, especially on the utility side, kind of Peter's side, like how are they thinking about distributed energy resources and like how their utility business model might change. Like these have been being talked about. This isn't new, but always interested to hear kind of the present line of thinking. But one thing that always seems to come up is is this sort of evolution or revolution, whatever term you want to use, is it going to have people disconnecting from the grid, running their own, producing their own energy? And if you look at it back, I guess, to my engineering view, if you look at it, like I've read some reports, if every rooftop in the United States put solar on the roof, right, we would have something like 500 to 700, or is it 50 to 7? 500 to 700 gigawatts worth of generation. And so then if you say, okay, well, how much, given that solar has a certain capacity factor, right, it generates during the day, how much energy would this actually produce? It'd produce about 1.5 terawatt hours of energy. And right now in the United States, we consume maybe 4 terawatt hours. So maybe a third, could be generated. So the point is, it doesn't seem to me like real, black or white that, storage will be owned by the end user or by the utility or by, I think everyone's got a role to play. Like there's cases for each segment. On the residential side, it's not there yet, but it will be. But it's not going to be there yet for probably a very long time, if ever, where you would put so much storage at your house that you can still hang out and watch Netflix, when it's raining for a week. It's just not. It's probably never going to be practical. So, to me, it's a mix of these different stakeholders right now. The commercial industrial behind the meter guys, there's a really economic case for them. Same with utilities, if they can kind of figure out, this valuation part, which is solvable. It's just a lot of stakeholders and a lot to work through. But even long term, the residential guy probably gets more in the mix. But I think it stays. Everyone has a piece. There's not really going to be a single stakeholder, single answer.
So, how about me giving you an answer for that, Mike?
Please.
You asked who should own the storage?
Yeah.
So, who's an engineer in the room? So, what's the standard answer for a question like that for an engineer? We always get it right every time. What's the answer? It's called, it depends. You use that, right? So it always depends.
But let me,
So-
because on that point though, who owns it also speaks to who's going to get paid for it. And if it's owned by somebody, maybe it's not owned by the utility, but should they have some right to recovery through utility rate base because they're providing a service on behalf of the utility?
So I'm going to give you both sides of the equation on this one. So the it depends means that I as a owner of the business or home can pay for this storage, and I want the benefit thereof. And my utility, which several of the representatives are in here, years ago came up with a tariff or rate called the cost of solar. They know what it is very well, and I learned what it is myself because I signed up for it. But if you look at it, it's a formula, if you will, and there's a value proposition spread throughout, not the least of which is carbon reduction, the value of that, and a number of other things. And this is from the utility's perspective. And so they have a bottom line, here's your number, take it or leave it. Well, a lot of us have taken it. So my point is, the utility transferred to their customers the right or the option to participate in a PV program. And I'm saying, I'm putting out a challenge, the same thing could occur with storage, because I believe the full benefit of storage, I mean, you're working on it, so we could give you some more reasons, but there's a lot of reasons why we need storage. And so what I'm saying is, if I had a value of storage rate, then I may opt to go ahead and do that myself. And it could be that the utility doesn't offer near enough to justify it. But I like my lights on when the hurricane comes through. So, here it would be the tornado comes through. And so I might be willing to pay a premium. So that would be a business case for the homeowner, the business owner, to pay for the storage. And Scott, I'm going to pick on you. You still here? Yeah, there he is. He's reading his Scott Jarman, come up, wake up. So in 1999, you and I were on a whiteboard at Austin Energy, and we said there's going to be district cooling in Austin. And the first thing we decided before there were even any chillers is that there would be thermal storage. So my question for you is, and we did not prepare at all for this, but you're a long way past 1999, and your utility has experienced megawatts on top of megawatts on top of megawatts of storage in action. And we're not going to talk about the thermal side of it, but the electric side, is there in one or two sentences that you or Carl could say, what has that tens of megawatts of storage meant to the utility? What's it done? Is it any voltage or generation deferral or anything that you're aware of?
Well, it's definitely helped our district cooling business be successful in serving many of the downtown buildings and keeping the chill water rates lower, because the electric cost to run the district cooling plants is much.
Okay, so it's economic. So what he's talking about is avoidance of peak charges from the utility. And I'm saying that there are other benefits that are accruing back to the utility also, resiliency of the grid. Yeah. So the utility theoretically has calculated that into the rate.
I'm gonna go because we only have about 7 minutes left.
So the answer to your question was back to it depends. It depends on which hat you're wearing, whether it's the consumer justifying this investment or the utility justifying the investment.
Great. So we have about 7 minutes left, and I wanted to make sure we had some time for questions from the floor. So if anybody has, yes.
There was a bill introduced in the House of Representatives last July, I think, regarding a 30% tax credit for storage. Can any of you in the panel speak to where that might be, and the potential for a future tax credit? And I guess a follow-up question is, what would that do to the whole battery storage industry?
I was going to say I can probably speak to it just because I've been following it for a while. The current word I would say is that it's unlikely that something like that would get passed in the current administration. So I think a standalone, and part of the question has been, storage has qualified for the ITC if it's been installed along with a solar project because it's qualifying equipment. And so the part of the question was, can you get clarity on what that actually means? And then should there be a standalone storage bill that would allow you to just get the tax credit on the storage piece, even if you didn't put it in conjunction with solar? I think there's probably a better chance that you get clarity around the former than the latter. I think that the a standalone ITC, you know, it'd be nice to see, but it just seems like the writing on the wall is not in the immediate future. I think the IRS is looking quite heavily at the use case because, once again, we talked about stacked services and what storage brings to the table. So the way that the ITC works now is if you get any energy off of the grid, then that reduces the amount of the tax credit that you collect on a 1% per 1% basis until you hit 75% of the energy going into the storage system. You fall off a cliff there and you give back all of your tax credit. And as we were just talking about, if I'm providing ancillary services or voltage support or anything else with that storage system beyond just charging during the afternoon and then discharging in the evening, now I have a system that I can't use to do anything else, because if I'm providing regulation or doing anything, I'm taking charging energy off the grid and then putting it back on, and that disqualifies me from my ITC eligibility. I think the IRS and other people see the illogic in that current arrangement, and why invest capital. I mean, if the idea of the ITC is to invest capital on the grid and make the grid more efficient and achieve policy goals, then don't put in regulations that stand in the way of doing that, right? So I think that there's probably a reasonable chance that you get some clarity around that 75% cliff and maybe get that clarified there, but I'm still not 100% sure that you're going to get the 30% ITC through.
Okay, I think we have time for one more question. Go over here.
So I've sold residential solar for the last 7 years to consumers who are talking, and there is definitely a demand for residential behind the meter storage. I think the idea that you invest $20,000 to $30,000 in a system that shuts off hypothetically with the shutdown of the grid seems antiquated. But for Dr. Muhoro, one of those drivers for consumers investing in storage would be a time of use rate structure, which EDC has talked about implementing as a pilot program. Because then it gives an incentive for consumers to have a value and a return ROI in their storage. So is that something that EDC sees as a driver of storage for residential consumers?
Great question, and we will be launching April 1, open to everyone for time of use rates. So we are moving forward with that, and we're still in discussion on things such as, and I somewhat try to stay away from the time of use crediting as the language, but it's something that we've talked about as well. We do think that actually gets a better ROI for this. One thing, and I'll go back to the question of who owns this, and I like to say who's got the money. The person with the money is the one who ends up owning it, right? And so, and I say that as a joke, but one of the things we did about a year and a half ago was launch our Empower loan program, and that allows the utility can loan the consumer up to $20,000. That's the initial number we started with, and we're probably in the middle of adjusting that around, but it's $20,000 towards solar and or storage. It's on the face of your bill at a very low interest rate, because as a co-op, we have access to very cheap money. So if I could loan someone at, say, 2.5%, then I still recoup something from an adder on that loan, which actually, because of our model, which is not revenue-based but margin contribution-based, I could still recover what I would have lost on my margins. And so, coupled with time of use and being able to provide low-interest financing, I think gives a lot of options. So we're looking forward to it. We know we could see the benefits. To my friends who are generators, I tend to say I don't care where the electrons come from. They could come from the end of the line. We still, as long as we could still maintain the grid as we need to. And so we're excited to be able to offer that kind of thing to our consumers, and we think that will drive it a lot more.
Great. Thank you. I want to thank all of you for sitting so attentively, and I want to thank our panel. Excellent. Thank you.